In this video, we're just going to spend a little more time talking about a few more terms that go with this logic that we've been learning. So with the next few slides, we're just going to assume that P and Q are the following statements. P is that a shape is a square, and Q is that a shape is a quadrilateral. Now, if we have the implication P implies Q, it tells us that if a shape is a square, then that shape is a quadrilateral. Our first term, the converse, drives the implication of the statement backwards. It flips the arrow. So in this case, we have if a shape is a quadrilateral, then that shape is a square, or all quadrilaterals are squares. And we see that the converse to this statement is not always true. This converse, this part right here, is not true. All quadrilaterals are not squares. Look at rectangles. But the converse is true sometimes. For example, what if we had the statement, if an angle has 90 degrees, it is a right angle? Well, the converse of that is, if we have a right angle, if there is a right angle, then it has 90 degrees. 90 degrees. And we know that that's true. So the converse could be true, but it also does not have to be. So we have to be careful with these converses. Next, we have the inverse. The inverse is when you negate both the components of the statement. So we just negate, we originally had P implies Q, now we have not P implies not Q. So not P, instead of all squares, we have some squares are not quadrilateral. And we see once again that this is not true. Some squares are not quadrilateral, well, all squares are quadrilaterals. So the inverse also can be false. But the inverse, once again, could be true as well. If we go back to my last example, if the angle does not have 90 degrees, then it's not a right angle. That is true. So depending on the sentence, both the converse or the inverse could be true or false. So we have to be careful with these. Now moving forward, we have the contrapositive. If a statement is true, the contrapositive, unlike the other two, is always true. So when we do the contrapositive, we do both the converse and the inverse. We do both the converse and the inverse. We flip it. We flip the P and Q and negate both pieces. So here we have, if something is not a quadrilateral, then it is most certainly not a square. And once again, the converse, the contrapositive is always true. So now let's take you are 17 and you are eligible to vote. That is our P and our Q. The true statement is, if you are 17, if you're 17 years old, you are not yet eligible to vote. Or if I'm writing this in symbolic logic, I have P implies not Q. P implies not Q. The converse of this, the converse, remember, is just when we reverse the pieces. So finding the converse, we'll just have not Q implies P. Or if you are not eligible to vote, then you are 17. If you are not eligible to vote, then you are 17. And we see from our previous examples, the converse here is not true. If you're not eligible to vote, then you are 17 is not a fully correct sentence. You could be 17, but you could also be 16 or 12 or 4. You could have any age under 18 and still not be eligible to vote. Now we find the inverse by negating both statements. So the inverse here, negating both of these, would give us not P implies Q, negating both pieces. And negating both pieces tells us if you are not 17, then you are eligible to vote. If you are not 17, then you are eligible to vote. And once again, this could be true, could be false, depending on your age. You could be 20 or you could be 4. If you're 4, you can't vote, but if you're 20, you are eligible to vote, so then this statement would be true. Lastly, we have the contrapositive. We put both of those things together. So we flip the two statements and negate them. So here we have them negated. Now let's flip them. So the contrapositive of our original statement, which is written right here, would be Q implies not P. And remember, if our original statement was true, so should this. So let's see what we have. So Q implies not P would tell us that if you are eligible to vote, I'll just write it right here. If you are eligible to vote, I know I just spelled eligible wrong. Try to erase that L. Then you are most certainly not 17. And that's true. So the contrapositive comes out true. So that is converse, inverse, and contrapositive. 3 different ways of negating, in a sense, negating your statement. The contrapositive, or the converse could be true, could be false. The inverse could be true, could be false. But the contrapositive, if the original statement is true, the contrapositive is always going to be true.